Okay, so the first problem of this assignment asks us to identify whether the triangles are congruent using side, 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 angle, side, or neither. And in this case, the answer is going to be neither, but let's talk about why. So we only have two relationships that will show us triangles are congruent. One is that we have three corresponding sides that are congruent. The other is that I have a side and then the angle in between that side and another side, and the sides are congruent, the angles are congruent, and the sides. So let's look at this particular example and see what we can see. So I notice that there's a tick mark, this angle is marked as congruent to this angle. Then as I go counterclockwise here, this next side has a tick mark. Counterclockwise, this next side has a tick mark. And then this side that they share, of course, is going to be the same in both triangles. And so what you have is in order, we have an angle, we have a side, and then we have another side. Of course, that is not one of our relationships. So angle, side, side is not one. And so that is neither one of these relationships, side, 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 or side, angle, side, apply. So these are, we cannot show that these are congruent triangles. Okay, problem 2. So if we look at problem 2, we can see that we have a right angle, so we know all right angles are congruent, so this angle matches this angle. We also see that there's a side that's length 4, and we have another side that is length 4, so those sides are congruent. We can mark this right angle as congruent. And then we also have another side which is congruent that is marked 3. And so if I look at this, I can see that I can go, if I'm going to start at the side that's 4, and then I'm going to do the right angle, and then I'm going to do the side that's 3. I have side, angle, side. So start at the side that's 4, then the right angle, then 3. I have side, angle, side. And so these triangles are congruent by the side, angle, side theorem. Okay, so this is problem 3. And as I look at this picture, I'm trying to decide whether I can use side, 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 or side, angle, side for this, or maybe neither of them. And I can see that I have an angle that is congruent. And then after that angle, I have a side. So after this angle, I have a side that's congruent. So these two sides are congruent. And then I have this next side is also congruent to this side. And so the pattern there is angle, if I go in order, angle, side, side. Angle, side, side. Well, that is not one of our theorems. And so it has to either be side, 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 or side, angle, side to show that it's congruent. So this would be neither. Neither of these theorems show that these two triangles are congruent. So here we have problem 4, and I'm looking at these two triangles, trying to decide are they congruent. And remember, I can use side, 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 and side, angle, side. Anything else, any other pattern, and it would be neither. So I'm going to look at these sides and see if they match. And so here I have the smallest side is 4, and that's congruent to this side. So I could mark this as being congruent. Then the next side, as I go around the triangle, why don't we go in the order of from smallest to largest. So here I have the side that's 6, so I'm going 4 to 6, and the 6 length is congruent in both triangles, so those are the same length. And then the next one would be a side of 7. So here we have 7, and then we also have 7 on this one. So this does fit the side, side, side pattern. And so we know that these triangles are congruent using side, side, side. All right, for problem 5, it tells us that they want to know what value of x would make these two triangles congruent. And so we have this triangle I'm going to kind of shade blue here, and then the other triangle above, which I'm going to shade in red. And they're asking us to make them congruent. We already see that we have You can see this side right here has a tick mark. It's matching this side. And then we know that because this side is in both triangles, it's of course it's the same length as itself. So it's got, so far these triangles have two sides that are congruent. We know that we have a theorem that says if all three sides are congruent, side, 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 then it's going to be a congruent triangle. And so we have to make the 20x side be the same as the 22x minus 3.6. And so therefore we set up this equation here that 20x is equal to 22x minus 3.6. And we just go ahead and solve that algebraically. I'm going to subtract 20x from both sides. That's going to give me 2x on the right side. I'm going to add 3.6x to both sides, and so I will have 3.6 on the left side. Then at the next step, we're going to divide by 2 on both sides, and so I'm going to have x is equal to 1.8. So if we made x equal to 1.8, then these would be two congruent triangles. All right, in problem 6, we can see that we have a triangle, a pair of triangles, where we have one tick mark here, one tick mark here, so we have one congruent side. And then we have this angle, which has an algebraic expression for its measure. And the other one also has a algebraic expression for that corresponding angle. And then we have this, the other side, the next side, which has a double tick mark and a double tick mark here. So we can see that this is setting up for side angle side. And in order to make the side angle side, we have to make this x value such that 6x minus 27 is going to be the same as 4x plus 7. And so you set up this equality here and solve the equation. And so we're going to solve this equation by subtracting 4x from both sides. So now I have 2x on the left side and no x's on the right. I'm going to add 27 to both sides, so I have no constant term on the left side, but on the right side I'm going to have 7 plus 27, which is 34. Then I'm going to divide both sides by 2, and so x is going to be 17. So if we had x equal to 17, then I would know that these two angles are the same, and therefore the triangles are congruent. Okay, so we have these, in this problem 7, we're going to do a proof, and we want to show that if we know that C is the midpoint of BE, so they tell us C is the midpoint of both AD and BE. What does that mean for our picture? Well, if it's the midpoint, then I know that this length A to D, that AC is going to be the same or congruent to CD. And so I'm going to mark that as congruent because I know this point C is exactly in the middle of that line segment. We also know the same thing is true for the line segment BE, that C is exactly in the middle. So I can mark this length congruent. BC is going to be the same length congruent to CE. And when we know that, the other thing to look at is, so I'm trying to prove that these triangles are congruent. So remember, we can use side, 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 or we could use side, angle, side. Well, I don't know anything about this third side as far as the length goes. So that's probably not going to be side, side, side. So what I'm looking for is a side, angle, side. And so here's, if I'm looking at this, I have a side, and then here's the angle, and this is another side. So if I could show that this angle is the same or congruent to this angle, then I would be done, because I would know that I would have that side, angle, side pattern. And looking at that angle pair, we know that those are vertical angles. And we know vertical angles are congruent. So that's our plan for this proof. So what we want to do is we want to just step by step make those statements. And so the first thing we're going to do is we're going to write down what we were given. So we're going to say C is the midpoint of AD and BE. Okay? And how do we know that? They told us. It was given. That's the first step. The next thing we're going to say is, okay, if that's the midpoint, then I know that AC, that segment, and notice I'm going from the A to the C. So then I have to, when I match it up, I have to go from the D to the C. So I'm going in towards, from this angle on the outside to the vertical angle. So for both of them, I have to go from the angle on the outside to the vertical angle, from A to C, from D to C. When we're talking corresponding and congruence, we have to be very careful about that. And so AC is going to be congruent to DC. And similarly, I can say them both at the same time to save us some room. EC is going to be congruent to BC, or I could go from CB to CE. It doesn't matter as long as I'm consistent with the direction. And so I'm going to say, so since I went from A to C, how about we just keep going in the same order? So I went A to C, C to B. Okay, so I went D to C. I'm going to go C to E. So here we're going to say, all right, CE. Well, actually, I started with AC last time. Let's do that again. So I'm starting with this triangle. So I said AC last time was congruent to DC. So now I'm going to go CB is congruent to CE. And how do we know that? That's the definition of midpoint. All right. All right, so what else do we know? Well, as we look at this, I need to talk about that angle here. And so we can't just call it angle C because it's in two different triangles. So we have to specify, and I'm going to say angle ACB. Okay, so if we look at this, I'm starting with the angle, the one tick side, and then this congruent angle, the vertical angle. And so I'm going to go the same way. I'm going to say DC, and then I have to do E, which is up here. Kind of went off my grid, so this is E up here when I move my picture. And so I'm going to say angle ACB is congruent to angle DCE. So what I'm trying to do is make sure that I'm going from the one tick side to the vertical angle to the two tick side, from the one tick side to the vertical angle to the two tick side. So we're going to be consistent there. And so then, why is that true? Because we know vertical angles are congruent. Right? And so now we have the side angle side. We know that we have a side, an angle in between, and then the other side that are congruent. And so I can say triangle ABC is congruent to triangle DEC. See if I can write that better. DEC. And why? What's the reason? The reason is side angle side theorem.